A ticking time bomb lies beneath the Pacific Ocean, and it just cracked open, a fault so massive. It once sent waves taller than a 6-story building across continents, and now, scientists say, it's not done yet. This isn't a movie trailer. This is real. It's happening right now, in Russia's Far East, where a monstrous megathrust fault just ruptured with a magnitude 8.8 earthquake, and the next slip could trigger a tsunami that hits the US, Japan, Hawaii, and more in hours. What really happened in Muanlian? Why is the Pacific Rim on high alert? Are we ready for what comes next? Stick around, because this isn't just a story about an earthquake, it's about a silent monster waking up beneath our oceans, and the world's race to survive it. Let's dive in. Ground shake of the century. Right now, geologists and seismologists are watching an ominous tectonic boundary beneath the Pacific near Russia's Muanlian, Kamchatka-Kuril Trench, a massive megathrust fault. This fault has already spawned a magnitude 8.8 quake on 30 July 2025, a seismic event that ranks among the largest ever recorded. And while the immediate event has passed, experts warn that another breaking is inevitable, posing a dangerous tsunami threat that could reverberate across the Pacific Basin. What makes this fault so critical? It lies at the juncture of the Pacific Plate subducting beneath the North American, or Okhotsk, plate, converging at several centimeters per year. It has historically produced some of the world's largest earthquakes, such as the 1952 magnitude 9 event that triggered an 18-meter tsunami and killed thousands in Severokurilsk. Today, the scientific world is racing to understand the risks, potential triggers, and global stakes. 1. The megathrust fault. Why it matters. What is a megathrust fault? A megathrust fault forms at subduction zones where one tectonic plate dives beneath another. These regions typically produce the largest earthquakes on Earth when locked sections suddenly slip, displacing massive volumes of ocean water and causing tsunamis pools like waves, sometimes hundreds of feet high. The Kuril-Kamchatka Trench is one such zone, a long, seismically active boundary stretching from the Kuril Islands to Kamchatka, fed by the Pacific Plate's steady descent beneath the Okhotsk, or North American Plate, at roughly 6 millimeters per year. This trench is known for repeated great earthquakes including 1952, Severokurilsk, M8.8 to 9.0 with approximately 18 meters tsunami waves and thousands dead. 1737 event, perhaps M9.0 to 9.3, with massive tsunamis recorded by early Russian explorers. 1963 and 2006 Kuril Island quakes, both M8 plus events that generated tsunamis affecting Japan and even California. 2. The July 2025 M8.8 earthquake, a wake-up call. On 29th July 2025, at 23 hours 24 minutes 52 seconds UTC, a magnitude 8.8 megathrust earthquake struck roughly 119 kilometers east-southeast of Petropavlovsk-Kamchatsky, off the eastern Kamchatka Peninsula. It occurred at a shallow depth of approximately 35 kilometers, typical of tsunamigenic events. Highlights magnitude M8.8, making it tied as the 6th largest recorded globally. A foreshock of M7.4 occurred about 2 weeks earlier, raising concerns. High aftershock risk. USGS projected nearly 24% chance of M7+, 96% chance of M6+, and greater than 99% chance of M5+ in the following week. The resulting tsunami, locally, Severokurilsk saw waves up to 17 meters, and even up to 30 to 50 feet in some areas. Across the Pacific, Hawaii saw approximately 1.7 meter waves, Japan approximately 1.3 meter max, French Polynesia up to approximately 2.5 to 3 meters, while much of the US West Coast saw approximately 1 meter or less, all smaller than feared. No tsunami-related deaths in Russia, 1 indirect fatality and injuries in Japan, minor damage in California, credited to effective early warning and public preparedness from decades of planning. 3. Why was the tsunami smaller than expected? Despite the quake's scale, the tsunami impact across distant areas was muted relative to past events. Experts point to several reasons. Moderate seafloor displacement compared to 2011 Tohoku or 1952 events, the actual slip near the trench was limited. No major underwater landslide occurred, which can amplify tsunamis unexpectedly. Fault mechanics. Slower rupture, deeper slip or heterogeneity in stress may have reduced tsunami generation efficiency. Modern tsunami warning systems, PTWC and national agencies issued alerts early, leading to evacuations of millions without loss of life in most regions. 4. Why scientists are still worried, what's next? This megathrust fault remains highly stressed. Historical records and geology suggest recurrence intervals less than 300 years, with the last great event in 1952. Key concerns. The recent quake may have left substantial elastic strain in adjacent locked patches, making another rupture possible, potentially sooner rather than later. Aftershocks pose significant continuing hazards. More M7+ aftershocks could trigger local tsunamis or infrastructure collapses. Stress transfer across the Pacific Ring of Fire. Some studies suggest that large earthquakes may alter seismic probability elsewhere, raising alert in Japan, Alaska, the US West Coast, and other regions. Indeed, scientists warn West Coast residents to review emergency plans, assemble go bags, and remain vigilant. The same tectonic forces lying beneath Muonlian are at work beneath Seattle, San Francisco, and coastal Japan. 5. The global tsunami threat. If this megathrust fault ruptures again, particularly if a deeper or larger slip occurs, the consequences could be dire. Severe tsunami risk for coastal Russia, Kuril Islands, Japan, and Hawaii. Risk of wave propagation to the Americas, especially Western Canada, California, Central and South America, all already on warning. Supply chain and infrastructure impact globally. Even modest waves of a few meters can disrupt ports and shipping lanes. Psychological stress on populations already traumatized by past disasters. Many evacuees reported panic memory from 2011 or 1952. 6. Preparedness and the way forward. Effective warning systems. Institutions such as the Pacific Tsunami Warning Center, PTWC, and national tsunami agencies acted swiftly, issuing alerts across time zones within minutes to hours. Evacuations, public announcements, automated alerts, and drills played a key role in minimizing casualties in Japan, Hawaii, and the US. This stands in stark contrast to coastal communities in 1952 and 2011 with slower responses and greater loss of life. Community-level preparedness, continued public education, drills and evacuation planning remain essential. Local building codes in remote Kamchatka helped limit collapse during the tremor, proof that hazard-aware construction matters. Funding must be maintained for seismic networks, monitoring stations, tsunami sensors, and communication networks. Scientific monitoring and forecasting. Aftershock forecasting by USGS and others remains crucial. The chance of further M7+ aftershocks in weeks is nearly 1/4. Ongoing research into megathrust rupture dynamics, including modeling stress heterogeneity, frictional effects, and dynamic re-strengthening, helps assess future hazard P potential. 7. The silent warnings. The Kuril-Kamchatka subduction zone is one of Earth's most powerful seismic sources, capable of producing earthquakes above magnitude 9 and generating massive tsunamis. On 30 July 2025, a magnitude 8.8 megathrust earthquake struck the fault, triggering tsunami warnings across the Pacific Ocean, though wave heights were much lower than worst-case predictions in most distant regions. Locally in Russia, wave run-ups of up to 17 meters occurred, causing damage in Severokurilsk, but strong building codes helped prevent fatalities. Despite the quake's size, the tsunami was less destructive than feared due to moderate seafloor displacement, absence of contributing submarine landslides, rupture characteristics, and effective warning systems. Aftershocks remain likely, including possible magnitude 7+ events in the days and weeks ahead with potential tsunami risk. Global preparedness, from PTWC alerts to community evacuation plans, help prevent a repeat of past disasters like 1952 and 2011. Scientists warn another rupture on the same fault could strike. The Pacific Basin's coastal communities must stay ready, as the seismic risk hasn't gone away. Standing on the edge of a tsunami ticking time bomb, the megathrust fault beneath Kamchatka and the Kuril Trench is far from silent. The July 2025 magnitude 8.8 earthquake was a stark reminder of the raw power still contained beneath the sea floor and a wake-up call for the entire Pacific Rim. Although advanced warning systems, community preparedness, and historic lessons prevented catastrophe this time, scientists warn that stress still accumulates along the fault. With aftershocks brewing and the tectonic strain mounting, another earthquake and tsunami could arrive at any moment. Coastlines worldwide, from Russia and Japan to Hawaii, California and beyond, must remain alert. Preparedness isn't optional, it's essential. The next rupture might be bigger, closer to shore and more destructive. We've seen the warning signs. The earth cracked, the ocean moved, the world held its breath. But this might just be the beginning, because beneath the silence of the sea, the megathrust still breathes, and when it strikes again, it won't knock twice. So now we ask you, are we truly ready for the next Pacific-wide tsunami? What if it hits your coast, your city, your home, and who will sound the alarm before it's too late? Let us know your thoughts in the comments below. Do you think the world is doing enough, or are we dangerously unprepared? Share this video, because the more people who know, the more lives we can save, like if you learned something new. Subscribe for more eye-opening content about the forces shaping our planet. Stay alert, stay safe. This was just the first wave.